And this week, we're really going to focus on learning the basics of Python. And then we are going to do some demonstrations on how you can use a Python-based library to do a little bit of simple experimentation with some AI-based approaches. And again, as I mentioned last week, this class is really going to be geared towards people who have had no experience programming in Python up to this point. We are really going to cover the basics. So if you do have some experience in Python already, this might not appeal to you too much. So just keep that in mind. We're trying to, again, gear this class towards the non-specialists. So we're going to really teach in the time that we can, the basics of Python without going into too much detail. So we're going to be covering that mostly today. As before, if you have any questions, feel free to save them until the end of today's workshop, but also Ibrahim might be available to answer some Python-specific questions in the chat as well. So you can share them then in the chat or hold on to them till a little bit later on when we're done. This workshop part will take about an hour or so. Also, we are hoping that folks can stick around at the end of the workshop today to give us a little bit of feedback as well on what you thought worked and what didn't work with this whole workshop series. So again, this is the very first time that we are running this workshop, so we want to get a better sense of how we could improve it for future iterations as well. So again, please stick around probably after about 1 o'clock or so to help us shape the future of this workshop series. So, as I said, this week I'm going to attempt to get a little bit more hands-on with how we can use programming for AI-based research and other work. So thus far in our workshop series, we've been looking at, different out-of-the-box tools, and we are going to learn a little bit about Python so that we can move from those out-of-the-box tools to using a programming-based approach. So as I said, I'm going to try to, in the amount of time that we have, teach you a little bit about Python. I can't really teach everything there is to know about Python and programming in 1 hour. When I first learned to program, it was over an entire semester as an undergraduate. So my only goal today is really to try and demystify the process of programming a little bit, so that if you decide after this class you want to learn a little bit more about programming, perhaps you will find that process a little bit easier. We've also shared some resources on our webpage, which maybe we can share the link in the chat, that gives you a little bit more resources on if you want to learn Python a little bit more in depth. And so there is a whole collection of links on the page this week that might help with the process of both installing Python and also learn about it a little bit more. So visit our website for that. One thing I wanted to bring across with today's workshop as well is not to necessarily worry about memorizing the programming syntax that you're about to see. I think in today's workshop, really focus on trying to understand broad programming concepts. You can always look up code syntax online. And again, we will share some resources on our website to do that. And I'm constantly doing it. And I think particularly since I imagine a lot of us may use programming intermittently in our work, being able to look up how to do something on the web is a really important skill to have. So don't worry so much about the code that you're going to go see today, particularly because we're going to go through it quickly. Just try to broadly understand the concepts of Python. So before we look at a little bit of code or start talking about Python specifically, I wanted to talk broadly about the notion of programming. So programs really revolve around instructions. And so you can think of instructions as essentially building blocks. So for example, an instruction might be do this, then do that. If this condition is true, perform this action, or maybe perhaps do this action. Or maybe perhaps you want to do a particular action 27 different times, or maybe keep doing this particular thing until this condition is true. Those are all examples of instructions, and instructions essentially are the building blocks of what we will do with programming and Python specifically. So we have a sense of what programming kind of is that revolves around instructions. I wanted to touch briefly on what is Python. So simply, Python is a programming language. All programming languages have different syntax for writing instructions. So how you do something in C or Java or BASIC, which are all different programming languages, will have a bit of a different format than we will see when we look through our Python examples. Python instructions are generally contained within a text file. This text file generally has the extension .py, and each line of the text file essentially usually contains one Python instruction, but you can have them span over a couple of lines as well. So to get a little bit of an example of this, let's create a very simple Python program from scratch. I'm going to do this within a text editor called Atom. And we have a longer form video on our website that goes more into how you can use Python on your own machine. Today, we're going to use a little bit of a different approach, but for this first example, we're going to create a very simple Python program in Atom. So, and you can use any text editor, even Notepad is fine. But I'll just create a new file. I'll just call it simple.py. So that's the file name. And then what we're going to do is just create a variable. So maybe we'll create two variables. Number 1 equals 10. Number 2 equals 20. And then perhaps we will add those together. So added equals, and we'll get more into what this actually means as we go through the basics of Python. But I just wanted to show you conceptually what a Python program looks like. So essentially what we have done here is that we've declared two variables, the number 10 and the second number is the number 20, and then we're going to add them together. And then we want to obviously print those out so that we can see what the results are. So this is the basics of a simple Python program. It's, we've declared two variables, given them values, and then added them together and then printed out the result. So we have this program. How do we actually do something with it? How do we run it? How do we get those results? And essentially what you would do is, to do this, you would essentially on your personal computer, you would have to install Python. And then you would run this program through the Python interpreter. And so that has to be done via the command prompt, or perhaps if you're using a Macintosh computer, a terminal. And I go again through more detail in this in our longer form video, but you would essentially, once it's all installed, you would type Python and then the file name that you've called your Python program, and here it was simple.py, and then you would press enter, and you can see that it will print out your results. So we'll go through this in more details as we go through the basics of learning different things and the things that you can do with Python. But the key takeaway is that if you want to do something with Python, particularly on your local machine, you need to put instructions in a text file, which is then run through something called an interpreter to actually do something. And again, our longer form video of this week goes to that in far more detail. So as I said, to do all of this, like I just did, you need to have install Python on your computer. We don't have enough time to go through that today, but if you generally will take the approach of downloading it from python.org and following the instructions, it's available for a variety of different platforms, including Windows and Macintosh and Linux. You would generally want to choose the latest version, which as of this week is 3.11. And there, again, more research on our page, including a couple of different videos on how to install Python on a Windows machine and a Macintosh PC. So another option for doing work in Python without having to worry about setting it up on your own computer is using Google Colab. And so the URL is there. You can also probably type it in, there we go. The URL is there, but you can also probably type it into the search. And maybe perhaps if somebody wants to share that URL, that will also be helpful. But it's a very nice option to basically do work with Python without having to worry about all of the setup on your own machine. So let's take a look at Google Colab, and maybe I will minimize my slides here because I don't think we'll use them for the rest of the class period. We're really going to focus on doing things in Google Colab. So let's close that off. There we go. So this is essentially what Google Colab looks like. And so we all have access to Google Colab here at TMU as part of the Google Suite. And if you have any form of Gmail address, you should also have access to Google Colab. And it's a really nice environment to do some type of programming-based work without having to, worry so much about all of the steps required to do Python, use Python on your own machine. It's basically a web-based kind of sandbox or a space to do Python and other forms of programming. So essentially, when you come to Colab, you might see a welcome screen like this. And essentially what you will want to do actual kind of Python work is go to File and then New Notebook. And this will allow us to have a blank Python Code notebook. And essentially now we have the basics of a coding space where we can do our work. And so I'll try to go through a few things related to Colab before we start using it related to some Python programming. The first thing you might want to do at the top of the screen here is rename your files. We'll call this just example. And they usually have this little extension of .ipy. It's a Python notebook, so IPYNB. So essentially with Google Colab, it kind of organizes itself around code blocks. And within the space here, you can essentially see that all of your code blocks generally are contained within this middle section of Google Colab. So you can essentially type Python commands in here as we did before. So number 1 equals 10, and then number 2 equals 20, 20, and then we won't add them. Well, maybe we'll try to add it equals number 1 plus number 2, and then we'll print it out as we did before. So print added. So now we've essentially got the basics of a Python program as we had before. And if we want to actually see the results of this, we can essentially just press this little play button here. And depending on the type of program that you're running and the amount of steps the time it will take will vary. Usually quicker than this. Essentially, while it's playing, it'll do this little circular thing. There we go. So now we have the result. So essentially, you can organize this, which is called a notebook, to have a variety of different, Python instructions. And anytime you want to run these instructions, you can either press play, or there is a shortcut for doing that as well, which is Control-Enter. So you can have a variety of different code blocks. You can just keep adding them by pressing code. And so we could do another set of Python code here as well. You can also add text as well. So if you want a little bit of text in between your code blocks to perhaps explain something related to the code, you can also put in text blocks as well. Oftentimes these Python notebooks or these Colab notebooks are used as tutorials, so it's often nice to put a little bit of text between them so that you can kind of explain what you would like to do. You can also, like if we did another code block here just for a second, number equals 3 equals 30. You can also move these blocks around a little bit as well. So if you hover over here on the right-hand side, you will see a couple of different options on, being able to move them up and down. I believe, yeah, there we go. You can still see it. You can also delete them if you didn't need them as well. So you can do a few other kind of operations on these different code and text blocks when you highlight over here on the right-hand side. So you can delete that there. So before we kind of move away from this, there's a couple of other things I wanted to highlight. You can also save these notebooks as files on your own local computer. So if you had a really interesting example that you wanted to share with your colleagues, you could go to File and then Download. And there's a couple of different options. You can download them as notebooks, or you could download them as Python files. And conversely, you can also open notebooks as well. So for example, if somebody provided you with a notebook that you wanted to work with in your Google Colab space, you could also do that. And so you could open a notebook and see exactly what they had worked in as well. So that's essentially in a really quick run through, that's Google Colab. It's really a nice way to practice and play around with Python code without having to worry about downloading Python to your own individual computer. So if you wanted to, perhaps if you want to do a little bit more serious programming, you probably would want to install Python on your own computer at some point. But Google Colab is a really great way to get your feet wet. And if you want more information about how to install Python specifically and how to use it locally on your own computer, our longer form video on our website goes through that in a little bit more detail. But for the remainder of today's workshop, we are going to go through some different Python examples using the Google Colab just to simplify things. So I just deleted the code block that we just had, and I want to now, now that we have a little bit of sense of, what Colab is, I wanted to go through a little bit of Python as well. So we're going to start going into the code a bit now. So before I do that, I wanted to also talk a little bit about variables. And so programming work really revolves around data. And that data generally lives within variables. And so you can think of variables as essentially as a box for your data. To put data in that box, you essentially need to assign a value to a variable. And so in Python, variables have a couple of different rules you have to follow. So for example, you have to give them a kind of specific name. And the name, for example, can only be one word with no spaces. It can only use letters, numbers, and the underscore character, and it cannot begin with a number. Variables in Python can be a variety of different types. We won't go through them all, but some common data types include strings, integers, which essentially are whole numbers, or floats, which are numbers that have decimal points. And there's a whole bunch more, but those are the most commonly used ones. So let's look at a couple of different examples of how we can declare Python variables within Python. I'm going to mostly copy code back and forth here as we do this. But essentially in this example, as you can see here, maybe I'll make it a little bit larger so we can see it a bit better. We have declared 4 different variables, and the format essentially that you would use to declare these variables looks a little bit similar no matter what the data type is. So in this first example, we've declared a age, which is an integer because it is a whole number. Then we have declared a temperature, which is a float value because it has a decimal point. We then declare a string, which obviously is a string and has to be contained within quotation marks. And then our final value is a Boolean value, which essentially is a value that can have a variable that can have the value of true or false. And in this case, we've defined it as false. But with each one of those variables, you can essentially see they follow a little bit of a similar format when they are declared. They have the name here on the left-hand side, then they have a equal sign, and then the value. And so in the case of these number-based ones, you don't need to put quotation marks within them, and you don't for Boolean values as well. But for strings, they need to be contained within quotation marks. And so that could be single quotation marks or double quotation marks, and we're using double ones here. So if we want to use these variables in other code blocks, we have to press play again and run it. And now if we wanted to print any of these values, we saw an example of how to do that before, but it's essentially print. And then within brackets, you will need to put the variable name. So let's just print out the full name. And now if we press play here, we will see that it is printing out the full name. So one of the nice things about Python is that you don't have to declare what variable type it is. Python essentially figures that out for you. So in these cases, we didn't have to define this one as a string or this one as a Boolean. It determines what it is for you based upon its value. And that is not always the case with other programming languages like C or C++ or Java. But as one of the things that makes Python a little bit more user-friendly and well-suited for beginner programmers. So we've essentially learned how to declare some values. Let's try to do something with some variables, and let's try to do some simple math. And what we're going to do in this example is I'll start a new code block. We're essentially going to declare some variables, but we're going to declare them using some mathematical operations. And it's all relatively simple. It's done in the same way. The variable name is here on the left, and then we will use some mathematical variables. And most of them make sense. So the first one, we're adding them. The second one, we're subtracting. This third one, the division symbol is the slash. Here we are doing multiplying, and that's essentially with the asterisks. And in the final one, we're going to do a modulus, if you know a little bit more about that. So again, we play it, and we can print it out as before. So if we want to print out, for example, the addition one, and run it, we will now see that we have the number 14. So again, that's a simple way to do a little bit of work with some math or some numbers. But let's play around a little bit more with strings as well. So let's start off by trying to concatenate some strings together, which essentially means putting the separate strings into one string. And I'll show you a simple example of how we'll do that. So again, similar to what we did before, we've declared 2 different strings this time, my first name, my last name, 2 variables. And then we're going to define a third variable, but we're going to make up that third variable by putting in the first name, that string, putting in a plus symbol, then having an empty space here, and then another plus symbol, and then the last name. And essentially what that plus symbol is allowing you to do is to concatenate different strings together. So now essentially we have declared this variable of full name, and all of them are combined together into one string. So when we run it, and I'll use the shortcut now to Control Enter, you essentially now, this full name, when we print it out, is a combination of my first name, a space in between them, and my last name. And so that's, again, a simple way to do a concatenation of a couple of different string variables. So we've already seen generally a couple of different ways of how to print out variables. And I wanted to point out one other way that we can print them out. There's a couple of different with the different variations of Python, there have been many different ways to kind of print out variables, but I wanted to show you one that's a bit helpful, particularly when you're trying to print out multiple variables, for example, in one sentence. And so let me do another example here. And again, I'm just copying and pasting. Let's add another code block. And so in this example, again, we've declared two variables, a string variable with the called city with the value of Toronto, and a float variable with the temperature of -10.5. And again, it's a float because it has a decimal point. And so I'm printing out here, but essentially with this kind of format or syntax for printing out, it can be quite handy because if you put these little curly brackets within the string that you're trying to print, and then use this dot format, you do a dot and then format, and then within brackets, put the variables that you would like to have fill out these individual spaces. It will essentially put these variables within these parts in your string. So we print that out, or run it, sorry. You could now see that we have our sentence as before, but with the variables that we've defined filling in the space of these little curly brackets. And essentially to do that, you use dot and the keyword format, and then a list of the variables. And then these variables will go into these spaces based upon the order that you've put them here. So again, a simple and kind of more effective way to do printing when you want to print out a variety of variables in one string. And again, hopefully, Ibrahim, you're able to answer some of the questions I'm seeing in the chat. But if not, I will get to them when we are at the end of today's workshop. So you can also use this same type of approach with declaring variables as well. So I'll go through another quick example that does kind of the same thing. Another code block. But we've declared three different variables, three different strings in this case. And so name equals Stuart Duncan, hometown equals Toronto, year equals 2021, three strings. And what I want to do is define a fourth string in this case, so introduction. And then you would put equals, and then again, the same format as we saw before. So you essentially use that dot format and the variables that you would like to be filled in within the variable. And so essentially, you can use this kind of dot format approach for both printing out things, but also defining variables as well. So it's, again, if we were to print this out now, you would see that this variable contains the different values that we have put into our, that came from our other variables. And so you can use that dot format approach in a couple of different ways, both defining variables and printing out variables as well. So now we have a bit of an understanding of variables and a little bit on data types as well, and how we can use them within Python statements. But the real, I guess, power of programming is not just running statements from start to finish. Things get a little bit more dynamic when you want to use them to perform certain actions based upon certain conditions. And that's essentially what we call flow control. And flow control is typically done within programming languages with if-else statements and loops. And so let me clean things up a little bit here. We got a lot of blocks. Maybe we'll try and remove a few of them before we get into looking at ifs and else. And you can see here, I'm just clicking on the garbage can in each case. So I'm highlighting over the block and I'm clicking on the little garbage can. So yeah, let's look at a simple example of an if statement. So essentially, it's pretty simple. So what we've done here is we've declared a variable, so a numeric variable with an age of 40. And then we do an if statement to test a condition. And in this case, the condition is whether the variable that we have defined, age, is larger than 40. And if this condition is true, we would then print out this statement here. So you are older than 40. So if we were to run this code block, you will see that it will print out because the condition is true. But if we were to change this to this number variable to 30 and rerun it again, it does not print out because in this case, the condition is false. So with an if statement, it will only essentially print out, which is this kind of statement here, when it is met as true. So let's make it positive again, or so that it will go true again. And one thing I wanted to highlight with Python generally is that in Python, code blocks are organized by using tabs. And so let's try to do something here to make that a little bit clearer. So I'll just put out another little print statement down here. This is a print statement. So let's change this to 30 again, back to 30. So essentially in this situation, what will occur is that it will, when it tests this age to see whether it's over 40, it will be false, and it will not print out this line, but it will print out this line because it doesn't contain, it isn't considered to be in the same code block because it hasn't been tabbed in one line. So if I run it, you can see that it is printing this second line because it is not part of this code block. But if I were to tab this line once, Python now considers both of these statements to be part of this one code block, and it essentially, both of them will be only printed if this condition is met as true. So if I run it again, it does not print either one of those statements because it considers them to be part of one code block because they're both at the same tab level. So if you've ever done any other form of programming, the Python does these kind of code blocks a little bit different than other programming languages does. Some other programming languages use things like brackets, where Python uses tabs. So again, just something to keep in mind. It becomes a little bit more important when you look at things like functions, etc. So let's just get rid of this code block for a minute. And so an if statement tests a condition, and that condition obviously will depend on what the operator is. So we did in our example that we just showed greater than, but it could be less than, it can be equal, it can be a combined, a whole bunch of things. One thing to note is now that we're using if statements, you really have, sorry, I already touched on this, but you really have to be careful of the tab blocks. So I wanted to show you one different example of an if statement where you might want, for example, some condition to be met when the first one is not formed to be true. So for example, you would do that with an if-else statement. So again, I'll do a code block and show you an example here. And it's done in the exact same kind of way. So we've defined an age to be equal as 50, a variable, and then we want to essentially test whether this age is 40. And if it is 40, we want this to print, so you are 40. But we want any other condition for it to print that you are not 40. So in this example, because the age is 50, this first condition is not true, and then it will print this second addition. It's a nice way to essentially have a default behavior when your first condition is not met. So if we run this, you can see that the second example, the else statement is run. If we were to change this to 40 and run it again, you can see that it is doing this first statement. So again, you can use an if-else statement when you want to have something occur when your first condition is met. So there is one more iteration of this if you are trying to test a variety of different conditions all in one code tag. So for example, let's just delete this one and do code again. So essentially what you will do in Python is use an elif statement. And so you can see how it kind of operates here. We've set an age of 30, and then we essentially are testing for 3 different conditions. We are testing for whether the age is 40. We are testing for whether the age is over the 40, and we're also testing for whether the age is under 40 as well. So we have 3 different conditions, but the process of how you define them is relatively the same. So if for the first one, and then elif for all the subsequent ones, and then you would have the condition that you are trying to test. So again, if we run this, we should see the statement "you are younger than 40" printed out. as we do. So essentially, it's using elf ifs is a nice way if you have more than two conditions that you're trying to test out. You can also combine comparisons in one statement as well, and you can do that using and or conditions. So again, another quick example. And let's delete our code block, start a new one. So what we are doing with this example, so we've defined two variables, an integer of 50, a string of my name, so Stuart. And essentially with each of these examples, we're trying to test two different things. And so in this first example, this if statement, if the age is greater than 40 and the name also equals Stuart, it will print out those this line. And the thing with an and is that it has to meet both conditions. So if this age here was 30, this would not print out because both are not being met. Where with an or, as you can see here in the second example, if either one of these conditions is met, it will be printed out. So for example, if we run this code now, you should see both lines because as we saw, the age is both over 40 and the name is Stuart. And the second one prints out because in this case, it has met the condition of the age being over 40. It hasn't met the name equals Bob condition, but the fact that this is an or allows us to essentially, this print statement will run no matter, as long as one of these two things are met. So you can essentially combine operators together to do a little bit more complex if statements. So all of this allows us to test a condition once, but what if we want to run a set of statements multiple times? And one way to do that is with a while loop. And I'll give an example of a while loop here. Let's get rid of our block again. So essentially what we've done here is we've defined a counter. So we're just going to use that as a numeric value that we are going to count up every time we go through this. And we want this while loop, which is just basically defined by putting while and then the condition that you are going to test. Essentially, this while loop will run as long as this condition tests true. And so in this case, it will keep running as long as the counter that we've defined is less than 5. And in each situation, we're going to essentially print out the value of the counter. And in every iteration through this loop, we are going to add a value of 1. So it's essentially going to count up. And then eventually stop once the value gets higher than 5 or higher than 4 in this case. So you can see here what happens. It prints it out 0, 1, 2, 3, and 4. And the reason it doesn't do 5 is because we've put this condition as less than 5. And so when it hits 5, it is no longer less than 5. If we had less than equal, it would also have printed out the 5. And you can see generally that the notion of the tabs here as well. So again, all of these statements are running in each loop because they are both tabbed out one tab, and they're considered to be part of one code block. So we've done a few things at this point. So we've learned how to store data in variables. We, to a degree, know how to control the flow of different programs. I want to, I guess, now introduce another really key component of programming, and that is functions. Functions are very helpful because they allow us to reuse code. And again, let me try to explain functions with a relatively simple example. There we go. So this is an example of how you define a function in Python. And so you can see it here in the first 3 lines. So every function in Python starts with the keyword def, so def. Then you would have a space and then the name that you want to call that function. And then you essentially have brackets, which gives you the option to pass in a variable into this function. So it essentially allows you to use a number from our value, a string, a number, whatever, from outside of the function within the function itself. And that is optional. You don't necessarily have to pass in a variable, but you always do need these brackets. And so if you didn't have a variable you wanted to use within the function, you would just leave them empty. But essentially with this function, what we're going to be doing is multiplying the number that gets passed into it by 2. And then we are going to return that number. And so essentially return means that you are going to do something with that variable outside of that function. And so, for example, this new number function cannot be used outside of this function unless it's returned to the larger outside program. And so, for example, you then have to essentially call that function with a variable passed to it. And so you can see here, we're going to print it out in this situation, but essentially what we've done is we've called our function, we've passed in a number, and then that number is being multiplied by 2. And so in this case, we should multiply 2, 4, and 10, and then we are going to print out what is returned. And so if we run here, we will essentially see 4, 8, and 20. So essentially what we've done here is run this function 3 times using a different variable in each example. And again, you can see part of the advantages with functions related to this, and that you can, we didn't necessarily have to retype out this code every single time. We could just, especially when you have longer functions with far more instructions, the value of not having to type out things is more pronounced. You can also define functions using multiple parameters as well, so it doesn't have to be just one. So here's a quick example of that. So we could multiply more than one numbers. So same kind of process, except we are multiplying 2 numbers that are passed in via the function. So 10 times 40, and we can run it quickly just to see what happens. But you can now see that you can pass in any number of variables to a function. And in this example, we did 2. So yeah, functions are very useful, and you can do a lot of really powerful things with them. The one thing I wanted to touch on before we we're going to slowly move towards doing things with AI in a minute, but there are a variety of different variable types in Python. We've gone through the simple ones like integers, strings, floats, booleans, etc. And I don't have time to go obviously through all of the different examples of the variables. Our longer form videos have some resources on that, but I wanted to go through one more that is particularly useful, and that are lists. So lists, if you've done any form of programming in other languages, are very similar to arrays. And essentially, it is a way for you to collect variables together. And you can define a list, as you can see here, by just giving it a variable name, then an equal sign. And then you put the list of items within square brackets. And in this case, we have 4 different strings. So we've defined a list containing pizza, bread, cheese, and orange. If you wanted to print out any of the individual items of this list, you take this little format here where you put the name of the list, then in square brackets, and then the numerical index. And the one thing to note with Python and most programming languages is that these arrays or lists always start with the index of 0. So you can see here that we're essentially going to be printing out each one of these values. So pizza, bread, cheese, and orange. And if you wanted to print out the entire list, you would just use food. So if we run this, you can see what we're doing here is we have pizza, bread, cheese, orange, each item of the list. And we can also print out the entire list as well. So lists can contain a variety of different data types. It doesn't have to be all the same. So for example, in this example, our list contains items of string, of a number, of this is a Boolean value, and also another string. And again, you just print them out the same way. So again, things 0 gives you car, and things 1 gives you 10. Lists can also contain other lists as well, which is a little bit meta, but I'll show you an example. So here we have a list again. So we've defined it the same way, but one of our items in the list is a list itself. Where it becomes a little bit challenging when you have lists that contain lists is how you print out the individual items for them. So let me just run this so it'll make a little bit more sense. But if you do, in this case, stuff and then 0, it's going to print out this first item, which is the entire list. But if you wanted to print out one particular item from this list, you would have to go stuff 0 and then do a second set of square brackets, which would be, in this case, if we put 1 here, it's going to print out the second element of this. So just note that when you have a list within a list, you need to have subsequent square brackets to get the individual items of that list. One other type of loop that we didn't go through that is particularly useful when you do work with lists is a for loop. Let's do one last example here. So essentially, we've created a list of 4 different vehicle types. And if we want to automatically kind of iterate through this list, which essentially means goes through it step by step, we can use a for loop to do that. And so essentially the way it works is that you have the keyword for, and then a variable, and you can define this as any variable. And then you go in, and then you put the name of your list. So in this case, car brands. And essentially what we will do is print out every one of these items. And so that's essentially what is happening here. Car will represent every item of this list as we loop through. And if we run it, you can see it work. So Ford, Chevy, Honda, Mazda are printed out individually. And it's a nice way to iterate through a list. And for loops are quite helpful for that. So everything I've shown you thus far has been a part of the built-in functions of Python, but Python also includes a standard library that includes a little bit more functionality. And to use that added functionality, you have to import modules. I don't want to spend too much time on this, but I wanted to show you a quick example of how it is done. So again, another code block. And so what we've done here is by default, if you wanted to create some random numbers, you can't do it without importing in the Python module for random numbers. And you would do that by going import, that's a keyword, the name of the library of the module you want to import, so in this case, random, and then we can use the function, the module. So if we run this, we will essentially get random numbers. It's running through a loop 5 times. And if we run it a couple of different times, we should have random numbers each time. But essentially what occurs here is that the key takeaway is that if you want to use some of the extra functionality of Python, you need to import modules. So if you're running Python on your machine, in addition to using these standard libraries, countless users have also created custom modules. And these custom modules are really helpful because they allow you to not necessarily have to recreate the wheel where you would have to program something from scratch. And you have to essentially add these custom modules to your Python installation. So if you're running Python on your local machine instead of Google Colab like we're doing here, you probably would have to install these libraries. And in the longer form video that we've included for this week, we go through some examples of how you can do that. But the web pages for these libraries will usually include details on how to do this, but this is typically done with a pip command, which I again go through in more detail when in that longer form video. But modules generally are really handy for doing AI-based work, as they really simplify the process of using artificial intelligence. And so people have done a lot of the complex programming work behind artificial intelligence, and then have created Python modules that kind of simplify the process of using them for people like ourselves who may not be non-specialists in using AI work. And so in the time that we have remaining, and I might not be able to get through all of the examples, but I'm going to show you some quick examples of how to do this with a Python library called Hugging Face Transformers. And so it's a really great library for doing AI work. And essentially, it provides pre-trained language models for a variety of mostly natural language processing tasks. Transformers is very, very customizable and a little bit complex. But fortunately, the Transformer library also has what are called pipelines, which simplify the use of these libraries for novice users such as ourselves. So let's look at a simple example of doing text summarization using Transformers. So we are essentially, with this text summarization, trying to take a long piece of text and use AI to automatically shorten it into, for example, a paragraph. And we are going to do that with an article. Let me just open it to show it to you here. So I've basically just created and this is probably pretty small, but there's essentially a text file, and this is an article that came out, I think, around the time that Elon Musk was finalizing the purchase of Twitter. And so it's about 500 to 600 words or so, and we want to automatically summarize this using a AI-based approach. And so again, summarizing one article might not be that challenging, but if you had to do this for 100,000 different documents, it would be laborious. And so again, that's where some of the advantages of using AI-based approaches can help with that process. So let's see how we can do that with Transformers. And so the first step, and we haven't gone through this yet before, but you can actually upload files to the Google Colab space that you want to do work with. And you do that by clicking on this little file here. And so we need to do our analysis on that text file we just had. We have to upload it to Google Colab. So I'll go back into my little directory here, and here's the file. And again, this was a relatively small program or a file, so it didn't take very long. But if you're uploading something that is quite large, it will take more time. And you can see here that you have quite a bit of space to do work on large data sets. So now we have our file available in Colab. Let's try to do something with it. And so, like I mentioned, the Transformers library is not one of those libraries that is included in Google Colab by default. And so you can install it by using a pip command. And so normally when you do a pip command, you would, on your local computer, you wouldn't have this little exclamation mark in front of it. But when you need to install something on Google Colab, you do. And every library that you try to use will have instructions on how to install it on your local computer, and you will get a little description like this where it says it'll essentially, they all have the same kind of format. So pip install, and then usually the library name. But again, look at the web page for your module to do that. And so you just press play, and it will take some time depending on the library. But what it is doing now is installing this Transformers library within the kind of Google Colab working space. And it's not going to essentially be done until it stops rotating there, as you saw. So it took about 12 seconds. So now we can essentially do work using this Transformers library because it has been imported. Well, we've added it to our Google Colab, but we actually haven't imported it to our code yet. And again, so this next line will be a little bit different depending on what library you're using, but you need to essentially import that module once you've added it to Colab. And in the case of the Transformers library, this is the syntax that you use. So we'll press play, and it will import the library for us. And again, it can take a little bit of time. We'll let us do its thing. So it took about 8 seconds, not too bad. So now that we've imported the Transformers pipeline, we need to instantiate an AI-based model. And I won't go through this code. I know I'm going through things relatively quickly, but essentially we need to instantiate it by calling a summarization method and then declaring a model that we are going to use for our summarization. And so Transformers has a couple of different models depending on what you are trying to do. And you can, specify some over others depending on what your needs are. And for this case, we're going to use the more common one, which is T5 base. So we can just press play, and this will take a little bit longer because it's going to actually download the entire pre-trained model, which in this case is 900 megabytes. It's going relatively quickly, but again, depending on your personal internet connection, it might be a little bit slower, but we're almost done. And when you can see here, it's still going. It's whenever it's complete, you'll see this little check mark, and it'll tell you a little bit of how much time it took. You will sometimes get warnings using these libraries, but in most cases, and in this case, you can ignore them. So just read the warning to see whether it's going to allow you to run it or not. So now that we've instantiated the model, we've imported the library, we need to do something with our actual file. And so the first thing we need to do is load our text file into a string. And again, I'm going through this relatively quickly, but essentially these commands are taking this text file that we uploaded and reading it into a string so that it'll be kind of more prepared to do our summarization work. So we'll just kind of quickly run this one. And it didn't take very much time at all. And then we will finally do our actual summarization. So this is essentially the code that you use to do the summarization. You set up another variable. You call our summarizer that we defined before. We pass in the string that we created before. And in this case, with Transformers, it works a little bit better if you do the summarization on the first 1,000 characters. And so this is a way to shorten kind of a string to have only the first 1,000 characters. And then there's a couple of settings you can set. So the paragraph that returns, you can have be a minimum length of a certain amount and a maximum length. And so in this case, I went with a minimum length of 30 and a maximum length of 130. But if we essentially run this, we should now get a summarization of our text. So we have to actually print it out as well. So we've done the summarization, but we have to print out the summary variable to actually see what it is. And let's do that. And you get a couple of different things back from this summary variable, but I'm going to be really focused on the text because that's what I'm more interested in. So essentially that's what I'm doing here is I'm printing the summary text. And you can now see that we have a 3-sentence summary of that entire longer article. And so again, you have Tesla boss Elon Musk will serve as the chief executive of Twitter. He has proposed some revisions to his verification process, and the move could stretch the billionaire thin, analysts say, which is not the perfect sentence, but it's not bad. So essentially, we've used here an AI-based approach to summarize a longer form article into something relatively shorter. And that's, again, possible using the Transformers library. So I think maybe we have enough time for me to do one more example of something you can do with the Transformers library. And so Transformers has a few other pipelines beyond natural language processing tasks. And one really useful one includes image classification. And so essentially, image classification is an AI-based approach where you use machine learning to try and assign a label to an image. So let's do an example with Hugging Face Transformers. And I'm going to show you what I'm going to try to classify first. So we have this picture of this dog. We want to get a sense of, the fact that this is a dog and perhaps what breed it is. So we're going to try to do image classification on this picture of this relatively happy dog. So the process is relatively the same. Let's start a new notebook just to keep things a little bit clean. But I'll go through this a little bit quicker this time. We will do as we did before. We will install the Transformers library. And at the same time as that's going on, I will upload my picture of the dog. So here's our dog. So you can do a couple things at once here. So now we have our dog image available within Google Colab while this is installing the Transformers library. I have to do it again because essentially every one of these notebooks is a new instance of Python. So I wouldn't have had to do that install again if I was using it on the first file I was working with. But as before, we need to import the pipeline as well. So we will run that. That will take a second. We also need to instantiate it as we did before. It's a little bit, the formatting is a little bit different, but the Transformers webpage gives you more information. But essentially, we've set an image classifier here, and we've given it, we are calling the classification method. We will run that. And by default, again, we use the default image classification model, and it has to download it. So there's a couple of things, but this, as you saw here, it's a 340 megabyte file that you have to download. Then we can essentially do the classification on our dog image. And so we will essentially we will call our image classifier with the file name that we uploaded here. So the dog JPEG, we will run it. And as before, once it's done running, we want to print out the value. And you can essentially see here, and it gets a little bit cut off, but essentially the classification model has determined that, and there's a few things printed out here, but it's essentially determined that our image contains a golden retriever, which is true. And you're essentially given a score for each of the things that it thinks the label could be. And that score essentially is for lack of a better word, the percentage it thinks it is right based upon what it's trying to do. So it's 92% sure, for lack of a better word, that this image contains a golden retriever. It's a little less sure that maybe it was a Labrador retriever or a Sussex Spaniel or a Clumber Spaniel or an Otter Hound. So again, a really nice way to automatically label an image. And we could do it with other images as well. So for example, here's an image of a poodle. And now that we've done all of that importing of things already, we don't necessarily have to do that all again. We can just upload our image of the poodle. There it is. There's the poodle. upload it to our Colab space, and just run a similar code segment for the poodle. And then we still have to print it out. And there we go. So you can see now that it's pretty sure that that image is a poodle. And there's a couple of, there's less of a chance of it being a miniature poodle. It is one of those large size poodles, not a toy poodle. So you can see here that it's successfully labeled the fact that it's a poodle. I'll probably kind of wrap things up there, but the one failing that I was going to go through related to this with another demonstration was that it works well for images where one thing is contained within the image, but it does not work as well for images like this, where we have a cat and a dog. It's essentially what it's trying to do with this image-based approach that we were just doing is give a label for the entire image. And when you have a cat and a dog, it struggles because it doesn't know which of these things it's trying to define. And there's another library or functionality available in Transformers that helps with this, where you can do object detection. Essentially, with object detection, it will look at an image and tell you that it contains a dog and a cat, without necessarily worrying so much about the species per se. But you can have essentially object detection works a little bit better when you have images with a whole bunch of different things and you're trying to determine what those individual things might be. So that's another option that is available within the Transformers library as well. So in general, as we wrap up, I think that was, I guess, a really quick introduction to both Python and how you can use libraries like Hugging Face Transformers and other ones to do a little bit of AI-based work. Particularly as beginning programmers, it can really be helpful to use these types of libraries to do the work. Again, we don't have to classify these things from scratch. We don't have to train these models with these pipelines. With a little bit of knowledge of Python code, we can do some really interesting AI-based work, which could have some interesting applications in both our research and our work. So again, Transformers is not the only AI-based library out there. There are far more. And I gave some examples of some repositories of interesting Python libraries in the links that we shared for this week. So again, this was very much an introduction to how to use Python. We have more resources on our webpage on how to particularly install Python on your own individual machine, some tutorials and YouTube channels, which are really great examples of how you can learn some more of the details of Python as well. And in our longer form video that I recorded, I go into more of the differences between using Python, using something like Google Colab, and how you would use it on your own individual machine. I go through a little bit more into how to install Python libraries. I also go in through some specific examples of how to work with, the web pages that modules have as well. So you can find out, where you might see the commands to install them and where you might see the commands to import them as well.